Hi, my name is Kelsey Pews, and this is my final project for Ecological Principles Applications to Conservation. For my study, I wanted to look at how plants were affected differently by change in altitude. I wanted to look at the way that they were affected in height, in leaf growth, length of the branches and or stems or flowers, and the different types of plants and vegetation that grew at a lower elevation versus a higher elevation. My hypothesis at the beginning of this study was that the vegetation at a higher elevation will overall be smaller in growth than the vegetation at a lower elevation. I ended up going specifically with scrub oak trees. So my hypothesis changed from vegetation to the trees will be overall smaller at a higher elevation than at a lower elevation. My plan for this study was to use the transect method and to do 2 transects at the lower elevation and 2 transects at the higher elevation. I planned to measure trunk circumference with a tape measure, leaf width from tip to tip at the widest point of 1 or 2 leaves per tree, and then to estimate the height of the trees as well. The last thing I wanted to look at was the overall growth pattern of the leaves, whether they were growing mostly at the top, if they were growing in densely or not quite as dense, and whether or not it was similar at lower elevation to higher elevation. The study area I chose is called Wild Rose Loop. It is a hiking trail in northern Utah. The elevation of the trail at the lower level, or lower area rather, is 5,192 feet. And as you hike to the top, the highest elevation you reach is 5,599 feet. The first time I went up there, I looked at all of the different vegetation that I could find. Things that I identified were the scrub oak, Russian thistles grew at the top of the hiking trail. Alkali Sacaton grass. There were elm trees. There was sage, 2 different kinds of sage. Green ash trees, as well as balsam root flowers. Some other things that I wasn't able to specifically identify were quite a few of the long grasses. There were tall, thin purple flowers and lots of leafy ground coverage all over. Most of the vegetation along this particular trail is mostly just longer grasses and trees. Here is the results of my study the second time I went back. I ended up sampling a total of 16 trees, 12 of them at the lower elevation, and I found as I got to the higher elevation that there were not nearly as many trees to measure. So I measured what I could in the 2 transects at the top of the trail, and it resulted in just 4 trees at the top of the trail. As you can see, all of the trees at the lower elevation had quite a large trunk circumference compared to the trees at the bottom. At the higher elevation at the bottom of the chart. Here is another table with my results. It shows my sample size, my sample mean, the variance and the deviation, along with the confidence interval. And we can see on this graph here that the mean of the lower elevation trunk circumference was far higher than that of the higher elevation. And the mean of the width of the leaves on the trees at the lower elevation was also higher, but it definitely wasn't as dramatic as a difference as the trunk circumference. After completing my study, I found that the scrub oak at the bottom of the trailhead definitely had larger trunk circumference, bigger leaves, they were much taller and had denser leaf growth. At the higher elevation, the trees stayed closer to the ground and had thinner trunks. The leaves were smaller, and even though they grew in very densely, it was not nearly as tall of a tree at the higher elevation, so it almost looked more like a bush rather than a tree. Some possible causes for the difference in growth at the two different elevations. At the top of the trail, which you can see in the photograph here, there's high winds, the soil is very thin and rocky. There's definitely cooler temperatures up at the top of the trail, especially as it gets into fall and winter time. There's low moisture as the water runs off and down the mountain. And there's not as many pollinators to not as many animal pollinators, rather, to carry the seeds and such to spread the trees and help them to grow. Here are some of the resources that I used for this presentation. Thank you very much.